Hello hams, this is Brett, AC0AE, and although this is not a ham project, it's a radio project, and thought I would share it with you. Maybe there's something to learn from this project that could be applied into ham radio. What this is this is a device that's this is the third one of these devices that I've made. And these will be strategically located around southwestern Kansas. And this is designed to receive outputs from electronics in gliders. And we'll have an antenna that hooks to this. And there's a Raspberry Pi in here. But anyway, this receives the signal similar to what aircraft transmits, fixed-winged aircraft, but this receives what's called a FLARM, F-L-A-R-M data. And anyway, this is a open source project, and it took me a while to get the components strategically fit in here. I have worked with Raspberry Pis extensively in my previous line of work, and I know what their shortcomings are. So the biggest shortcoming is with heat. Raspberry Pis, if they overheat once, they will always have a problem. So I put this will be mounted in a wall vertically like this, and it'll be in a metal building, and it could get hot. So we've got a duct here, an inlet here, and this fan is mounted so it's sucking air out through the bottom and out to cool everything in the box. So outside the box, of course, power. This is a nice little device for Cat 6 cable, Cat 5 or 6 cable to plug in here. And we're using LMR 400 to an antenna, and the antenna is right over there. This operates on 915 megahertz, and this is the fan, of course. So this is the Raspberry Pi. The Raspberry Pi also has a fan inside this case to circulate this air around, as well as heat sinks on the Raspberry Pi. Other components here is a software-defined radio. Like I say, the Raspberry Pi programs this to 915 megahertz. The software-defined radio provides power to the RF filter and amplifier here, and power supply here. It's relatively simple. You might ask, what is the white on here? That's hot glue to prevent the plugs from creeping out from thermal expansion. I tack them down with hot glue, and if you need to peel it off, it just peels off. It works pretty well. These boxes that I've made have exceeded the standard for what other people have made. These are real popular in Europe, and I think the reason that they are working, they're receiving gliders further away than what the design is, what they're designed for. And I believe the reason is I've took a different approach. My LMR 400 cable is extremely short. I mount this box close to the antenna as possible, and I mount it on typically an industrial metal building. We have a glider club member that's involved in the oil industry in Kansas, and they're kind enough to allow us to put these, scatter them around. So when the gliders are flying, you can log on to some websites and see the gliders in action. It's openglider.net is the backbone of this. There's a website called glideandseek.com that you can see the gliders. Of course, the gliders typically fly primarily in the summer. And so this receives signals from a commercial or a DIY version of a FLARM. And I will do a separate video on that. I have made a FLARM here. It has an external GPS and also a dipole antenna. This is going in my glider. So more on that later, but I wanted to share this box with the club members, and it might be applicable for some things that you are all working on here. It looks simple, but it's frankly a huge pain in the rear to get everything programmed and functioning properly. All right, thanks.